A very good afternoon to one and all present here. It is my proud privilege once again to introduce today's speaker, Mr. Suhas Kulkarni, our very own alumnus of EEE GIT. Mr. Suhas Kulkarni, presently Vice President, Head of Pre-Sales and Solution Delivery, Digital Solutions, Process Automation ABB Limited, has done his BE in Electrical and Electronics Engineering from Gokte Institute of Technology in the year 1995. He has been working for 25 plus years in the industrial automation domain. At ABB, he works with the top industrial customers across the world to realize their goals of digital transformation. During the past 25 years and more, he has held various roles in engineering, project management, R&D program management, and marketing functions. He has worked in industrial automation projects for various industries like iron and steel, cement, mining, specialty chemicals, petrochemicals, F&B industries, etc. With this very brief introduction, I, on behalf of E&E family, welcome Mr. Suhas Kulkarni for today's session on Introduction to Asset Performance Management in Industries. We welcome you, sir. Over to you.
Thank you, ma'am. I humbly request Mr. Suhas Kulkarni, sir, to begin with today's session.
Yeah, good afternoon. Just give me a moment. I will close my video and then put on the presentation mode. So it will take a minute or so, and then I will start. Is that okay?
Fine, sir.
And hope I'm loud and clear. In case I'm working from home. Generally, I have a good network here. I've been working, but in case there is any disruption, please, feel free to inform or, and so that, I can adjust. Okay. And yeah, I mean, we can have this session as very interactive session. You see, okay, so you are free to, interrupt in between, pose questions and all that. So it need not wait till end of, don't worry, because, I'm more or less conversant with the subject. So the flow will not change. So I will be able to talk and carry on. So in case you have any doubts, anything, please, and you feel you need something, please feel free to interrupt, ask questions, and let's make it a little bit more interactive rather than just a monologue where, I just keep talking something. So it should not happen. Yeah. Thank you. I'll just, close my video so that, the bandwidth then is better for the presentation. Yeah. Thank you so much. Present. Where do I have the present option? Yeah, here. Okay. Generally, we use are you able to see my screen now?
Yes, sir. Yes, sir.
Yes.
Yeah. Yeah, I hope you are able to see my screen. I will just wear my headset so that I don't get external disturbance so much while I'm speaking.
Visible, sir.
Hello. Am I audible?
Yes, sir. Yes,
Okay,
sir. Audible.
Okay. Just a minute. I'll connect to my big screen. So yeah. Okay. Thank you all, and thank you, Professor S.G. Kulkarni and the organizers of this wonderful event. That and I would also like to thank Professor D.B. Kulkarni, who had with whom I talked, and when we discussed that we should make, he requested to make a presentation. So yeah. I'm really thankful and really, excited to be part of this wonderful, community, GIT. I mean, I studied here and spent. I was the first. We were the first batch when the semester started in Karnataka University. Back then it was Karnataka University, and ours was the first batch, and I think we had the best time. Particularly me and many of my batchmates, we still cherish the wonderful time that we had in the college, and I can see still a lot of our professors still there, and that's what makes it really wonderful. A great faculty out here, very friendly, approachable, and I think we all feel proud to be part of this wonderful institution called Gopte Institute of Technology. Yeah. Okay, with this, I will start. Today the topic that I have chosen is the asset performance management industry. I'm sure many of you would not have heard about this in your curriculum. I mean, if you have heard, that's really great. But this is something that's really not spoken so much in the curriculum, but it's seeing a very wide application within the industry. So I thought this is something which is this topic is something that is generally very close to electrical and the mechanical engineers in the industry, and day in day out we work with large machines, whether it is motors, generators, transformers from an electrical point of view, or switchboards, or it could be from the mechanical point of view, boilers, turbines, and all those things. And these are something that are very important. These equipment keep the industry up and running. These need to be working 24/7, 365 days. Can't have failures. So these are the very demanding requirements that are there on all the equipment that I'm talking about. And yeah, it's what I'm going to talk about. How do we manage these things, in the industry? So how do we ensure that these equipment or the assets that we call keep functioning 24/7 with minimal maintenance, with minimal downtime, so that the industry is able to produce in a much better in terms of quality, in terms of timeliness, and in terms of profitability. Okay, so that's what is my topic about. So yeah, I mean, I think I'll not speak much over here. My Professor Datar has already given an introduction, but okay, just something that I would like to highlight. Yes, I've been working in this wonderful company called ABB. We are world leaders in electrical technology. And yeah, I've been working here now close to 22 years in this particular organization. Started right from, as just a senior engineer, and as a senior engineer, sales and marketing, went on to held senior leadership positions in engineering and R&D program management and all that. So now I have moved to something that's very interesting, is a very hot topic for, today's industry. So closely working with Industry 4.0 and as mainly in the digital domain. So we work with customers, and yeah, one of the topic that we work with customers is what I'm going to talk about, the asset performance management. I mean, this is what every customer would like to, because they have invested heavily on their assets, and they would like to see a very good return on their investment on the assets, so that they are able to manufacture well, they're able to produce quality products, they're able to make competitive products and all that. So that's why this connection, and I thought this is a very interesting field, something that's growing at an annual rate of 14 to 15%. This market is growing, so there is a huge potential for the young engineers to get on to this. Because you see, already, if you look at your standard, electrical projects and all that, and they have been, they have reached the maturity level where, today we know how to design a transformer, we know how to design a motor efficiently, and then we know how to set up a system together where you have an incoming power and right up to the usage of all the electricity. So we know how to do that, how to control it. So these are all, kind of industry 2.0, 3.0, and all that, functionalities that were there. And then when we talk about industry 4.0, we are talking about connected assets, where the assets are able to talk about themselves and their healthiness, what they're capable of. So they are able to give a lot of information about themselves. Today a transformer can tell, give a lot of information about itself. A motor can give a lot of information about itself with the smart sensors around it. And then we know what's happening to, I'm just taking some of the electrical equipments because you guys have, most of you people have learned about these, in your curriculum. And so these, the devices are becoming more and more intelligent with them. They are able to give information. So now idea is to collect all this information and make some meaningful, inferences out of these, and then present it so that we are able to run these very efficiently. Okay, so that is where is my background, and we've been India is now a center of excellence for this particular business. So from India, our Indian operations, we've done the complete product development, which caters to this kind of requirement, where we are able to connect to the devices over IoT, get this data, put it in a data lake, and then we are able to do analytics over it in terms of how the equipment has been performing. We are able to model these using, again, the new AML models to build up how the equipment should be behaving, and in case of failure, what kind of failure modes, how it can fail. So we are able to predict the failures and all that. So that's what we are doing from the place that I'm working, and I am heading the pre-sales. And so basically my work is to make a proposal to the customer. The customer comes up with the requirement of what equipment they've got and what they need to do, and what are their pain points, where they're having maximum failures. And so we build a solution around it, put up a proposal. So that's what I do. I have a team that works with me, and then I have a team that also delivers. So deliver the project. So once we get the project, we deliver this project. So this is where I'm working. So okay, so all a very interesting field for people who have, and I have myself, worked with all these equipment, right from looking at a small LT motors to a motor that is in megawatts, from a small distribution transformer to a power transformer, and all kinds of stuff. So okay, so let's begin. So that's the brief, introduction about this thing. So before we start, in our company, we have made safety as a habit. So this is what I would also like, the coming generation to take care. So please make sure you are always safe around. So I'm talking about two things. We have currently the coronavirus situation, where we have a very high possibility of this spreading. So please stay safe, avoid unnecessary gatherings, wear mask, use sanitizers, do not venture out if you're not well. So you protect yourself and others also. And if whenever you're traveling to college on a two-wheeler, make sure you have a proper helmet, or if you're using a four-wheeler, use seat belts. And when you are in college, especially in the labs where you have high voltages, 230 volts, or 415 volts, and when you're working with them, please ensure you follow all the safety norms. Make sure you're wearing safety shoes, and don't touch live parts and all that. So please, so this is very important. Make safety as your habit. Very important. So that's how we start all our meetings talking a little bit about safety. So it's so this is the culture that we've cultivated, and that has really led to some fantastic safety statistics for our company. So we have one of the top companies where we have a very safe environment in terms of working. Okay, good. Let's move. Okay, so what I'm going to cover today, in today's discussion is we will talk about what is an asset in an industrial operations. You see, asset. Okay, we will talk about that. Then, what is asset performance management? What is a big deal about this? Why are we talking about all this? Some of the figures that you're going to look at. I'm audible, right? I hope.
Yes, sir, you're audible.
Okay, so sorry, I'll keep checking in between because sometimes it so happens that you are lost and then you keep talking. So okay, thanks. So yeah, then we talk about the different operations and maintenance strategy that is currently followed for assets. We'll try to compare with how we generally do a car maintenance. We kind of do analogy with what you are. So you understand what are these. Then what exactly are some, we talk about. I'm not going to talk in depth about every component about the performance management, but we talk about a couple of things. One is where we discuss what is condition based monitoring. How do you look at the condition of a particular equipment, and then based on that you are able to decide when should you take it for a maintenance and do the maintenance relative activities. Second could be, a predictive maintenance. Of course, it partly derives from the condition, but then it also, can use the models that you're talking about. A lot of things are, especially things don't work with the standard physics-based, rules. A standard physics-based rule would say, okay, this happens and this happens. They are very logical. But today, with so much of data available to us, and with the computational power that we've got, we found that a lot of seemingly unrelated data are actually related. And then when you use artificial intelligence or machine learning models for this, you're able to connect a lot of data and then derive some meaningful insight out of it. And then that actually what helps really predict when the failure can happen. Based on the multiple, you are able to teach the models. Okay, when the last time it failed, this is what happened. The bearing. Obviously, when we know there is a when we talk about motor, there is a bearing failure, or a vibration is increased. It's a very clear case that bearing is not right. So, time to change the bearing. But that's something that is very easily can be inferred. But some of the things when you're looking at a complex systems, it could just be a small, blockage in the air pressure filter of a system, and then that could lead to multiple actions, and over a period of time it fails. So when is the right time where you are able to identify what has really gone wrong and what could really go wrong? So this is what we kind of do modeling with a lot of data. We are able to teach the models, and then the model is able to give you inferences. So that is what we're going to look at. Okay, and then we will also look at how typically these are implemented. A typical architecture, what we call of condition-based monitoring or predictive maintenance. How are we really deploying asset performance software in an industry? How it is connecting. So a very broad architecture just for you to understand. A lot of it is pretty basics. We can talk in detail in case you are interested. End of the thing, I will anyway send over this. My contacts are available in the department. So if any of you feel, you can always reach out to me. I would be glad to also take questions even beyond this seminar, where if I'm able to help you if you got something. Then we also look at some of the industry examples where I've mostly not disclosed the name because we are bound to not we have a lot of non-disclosure agreements with the customers and all that. So and since this being a very academic thing, I'm not really taking the customer names where we really did that, but I'm going to talk about industry, the industry, what did we do and what kind of savings they realized out of it and all that. So that is what we will look at in some of the implementation examples. Okay. All good till now?
Yes, sir.
Okay, thanks. Yeah, please respond so that I know, that the communication is on, else, it should not be. So please don't mind. I'll keep, in between checking that, whether the communication is
Okay,
on.
sir, it's fine.
Yeah, okay. So just thank you. Okay, so let's start with this. Let's try to understand what's an asset. Now, what's an asset? I mean, asset is something that's of value that can be converted into cash, and that is what typically, if you go to bank and all these, they talk about assets like that. Whatever that can be monetized becomes an asset. So everybody will own you. We all own assets. Some of us have a car, a bike, or a house, or a land. So everything is an asset. So all this can be converted into cash. So that is what we talk about. But for a company, yeah, I mean, of course, company also has assets like this. Company will have a building. Company will have cash. Company will have equipment, and all those things. So primarily, we could divide them into three types. One is physical, what that can be seen physically. Second is human assets, that are the people that are around. People are assets. And then the third could be virtual, one that is not seen or can't be felt, but like your IP rights, or so those things, the intellectual property, and all those things become the virtual asset. So that is what is an asset actually. And now, what is of interest to us, when we are talking about asset performance management is, okay, before that, so in any of these, especially when as I talk about an asset, asset that is used for production, what's the typical life cycle of an asset? Let's say you want to have a motor for hoist, so you plan, yeah, you need a hoist, you have a hoist application, and the hoist will be run. A prime mover for the hoist will be a motor, so you plan for it, you design the hoist, you design the motor, and then you go on to procure, who are the vendors who supply hoist, and you procure, then you install it, then you commission. Once the hoist is commissioned, then it's up and running, then you run, operate, perform, monitor. Over a period of time, you feel, no, this isn't enough. You started with, just an example, you started with a dual direct online starting, and then you realize, no, this is not good. I need a better control, better energy efficiency. So why don't I apply a drive for it? So you modify, you put a AC or a DC drive onto it to make it more smooth, energy efficient, and all that. And then you run, for whatever time that you need to run. And then tomorrow there is a life for that, and then that life gets over, you discard, and then either you replace by disposing it off, you decommission it, you remove it from service. So that is how typically an asset life cycle works. And you see, during this period of commissioning to so during this period of operate, this is where we have to make sure, while it does not mean that this is the actual time. This is the biggest time for the particular asset, whereas the other part could be a very small. This is something that will run for decades together. You're going to run equipment. That is where you need to make sure you get maximum out of it. That is what becomes the asset performance management. Okay, so what are the assets that matter to the customer? I just listed down some of them in an industry. You have static assets, you have rotary assets, you have electrical assets, and you have instruments. So if you look at static, static assets are something that don't move, and once something does not move, it is also relatively less prone to failure. But then we have the electrical, the rotary ones. The rotary ones are something that move a lot, and they are really prone to failure. So these becomes utmost important, because once anything is moving over a period of time, there is going to be a wear and tear, and when there is a wear and tear, then there is going to be a failure at some point of time, and so then they need maintenance. So that is what is the rotary part of it. Then we have electrical assets, which are again could be, some of them could be rotary. If you look at the electric generator in this case, or there are switch gears and circuit breakers that will also have some moving parts and all that. So, but by and large, most of them again in the static. But again, because of the current, heat, and all those things, again, there are failures on account of that. So exposure to the load cycle, how it's loaded when it is going to the peak and all that. So that's what causes the failure of some of the electrical equipment. Similarly, you have instruments, that could be a control system or a control valve or transmitters that are going to measure the pressure, temperature, flow. And it's just a long list. I just, put something so that, you are able to visualize what I'm talking about when we say the assets. Yeah. Okay. Fine. So now let's come to the topic of today's discussion. Asset performance management. So now this is a definition, that is given by a very reputed consultant in this particular field, and they call asset performance management encompasses the capabilities of data capture, integration, visualization, and analytics tied together for explicit purpose of improving the reliability and availability of physical assets. You see, understand reliability and availability. So that means any equipment that we were talking about in the previous screens should be working reliably. That means if let's say a transformer has to deliver, is rated for a particular kV, and it should be working in that. So it should be working in the rated range reliably. You should not have dips, so you should not overheat, it should not fail, it should not have a show. So that is what is the reliability. Then second part is availability. That means, as I said, many of these equipment need to be working 24/7. So they have to also be available 24/7. You can't switch it on and switch it off and then use it as and when you need. I mean, these equipment should be working reliably, and their availability should be very high. So that is what is asset performance. How do you ensure an equipment works reliably and is available throughout to deliver the rated performance? So that is what is the asset performance management about. And when we talk about it, includes the condition monitoring, predictive forecasting, and reliability centered maintenance. So again, these things are where, as I mentioned, condition monitoring is where we look at the condition and then decide what needs to, when the maintenance can be carried out and all that. Similarly, predictive forecasting is looking again at the conditions, modeling it, and then trying to forecast based on what could be the multiple inputs that are there around it, and then we're able to forecast when the equipment can fail and what is the time, what's the optimal time to get that repaired. So that way you prolong. You don't need to do it every now and then. That in that process you actually increase the cost. So we will look at some of the maintenance practices. So then you will appreciate what I'm talking about in this particular thing. Yeah. Okay. So you see these figures, and this is talking about an oil and gas customer, here in this case, and 70% of the decision, they are not aware when exactly it is due for maintenance. That means I just take a gut feeling and then, say, okay, now I have run the motor for, maybe 100 hours. I'm just giving a number. So X number of hours, and I need to take it for maintenance. Is that the right time to take maintenance? Because the moment you take it for maintenance, especially, motors, transformers, you need to shut it down. The moment you shut it down, the production is down, right? So is that the right time? Could this be prolonged for another? Let's say, as per the running rate, it comes peak of the time when just before Diwali, you have a huge demand for your products, and then it comes for maintenance just before that. So that would mean you would not be able to do your Diwali deliveries. So if could I then make sure, understand by any means, by any chance, that yes, no, I don't need a maintenance right now. I can take it during Diwali, when the production is relatively less. Everybody is on holiday. I've already produced and sent, and then that's the time I could do it. And can I prolong my maintenance, because as per theory it is due now? Can I do that? So that is what is asset performance. That's what helps you customer today. Customers are able to understand how long they can prolong and really have the maximum use of the equipment. So, and if you also look at the typical offshore platform runs at 77. I mean, these are just the figures. They're running at 77. So that means 23% of the maximum potential is not realized. So you have an opportunity for improvement there also. Now, why is this? Because you are taking planned shutdowns. You really don't know when you should be really taking, and you are doing, and that way you are restricting yourself and not really using the full capacity. And all in all, let's say even this is taken care, and there is an unplanned shutdown that happens. A motor fails, or a transformer fails, or a heat exchanger fails, or something fails, and this is, and the production down is easily about $250,000 per hour, and then you do it for 24 hours, you're $6 million gone in one day. You can't have this kind of shutdown, and I can tell you, you can probably buy many of these equipments multiple number of times rather than wasting this kind of money. So that is why it becomes very important, that we do right management of the assets. And you see, it could also lead to a 10 million, typically it's a 10 million barrels per day production, and that leads to almost $200 billion in annual revenue. See, these are the numbers, so that is what I was telling, this is something that, industry has started realizing. There is, a lot of demand to increase profitability, improve the performance and all that. And this is where one of the tools that can be used to improve all these things. So that is why companies are ready to invest on an asset performance management system. And once companies are ready to invest, there are jobs that are available to do that. There is opportunity available for people to get into that space. I've seen a lot of startups coming into this field, because not every customer can be addressed by a company like ABB. When we are talking with the top, for the Fortune 500 companies, because the kind of setup that we got, this thing that can be afforded only by larger companies. And then we have the smaller companies who are going to address this. That's where I've seen, we've seen a lot of startups coming into this space also. So there is a tremendous opportunity for all those things, and that's the reason I'm talking to you about this. So this is something that is pretty bright. Look at this. You can find a good career out in this particular sector. Okay, what are the challenges or the market drivers that are there? See, one is today we are having less and less resources. Especially I can see country like India, there's a lot of experience that is not there. People have retired. Younger generation does not want to do the maintenance kind of jobs. So that is something that we're having really unskilled people working in that particular sector. Then there is market pressures on for higher production and all that. Then there is margin pressure that I was talking about, where we need to make more and more out of less and less. Then there are old equipment. The equipment that has got old, but I don't have money, and neither I have the time nor I have the resource to replace it. So that's another part. So what do I do then? I look at enhancing the life of a particular equipment. So that is where and then assets are becoming very complex today, because as I said, today's assets are becoming much and much smarter. They are able to give a lot of information about themselves. So that also helps in making most out of the information that is coming out of these things. Yeah. Okay, so these are something that is really challenging us, and as one of the surveys shows that we can definitely increase. Companies are losing production because of unplanned downtime. And that's huge, right? I mean, if you're losing 5% of your production time because of unplanned downtime, that's and if you are able to even set right, let's say 50% of it, you're straight away increasing your profitability by 2.5-3%. Yeah. So yeah, so all these things drive this. So this is more about economics of why you should do and all that. Okay, let's get a little bit more technical now as to how actually is this clear, or is too small for you to look at the screen?
A bit small, sir, but we can see, sir. It's visible.
Okay. Right. I mean, yeah. I mean, generally, if you look at how traditionally people have been maintaining. If you look at long time back before processes were set, it was a very reactive kind of see something fails, you go and fix. That's what we do in your house, right? You don't replace a bulb before it goes off. When the bulb fuses or it does not work, you find a new bulb and repair. So that is what is typically it's done, and it's not that important that you can live. You can always live without light for a couple of hours, and then you can bring a new one and then fix it. That's what we call as a reactive maintenance. Now, there is something that could be called as a preventive maintenance. What is preventive maintenance? What you do, where you do it before anything else has happened. Like, you're changing the engine oil of your, vehicle, after, you run a couple of hundreds of kilometers or thousands of kilometers, go to a mechanic and say, sir, this has now been running for this, so you better change it. So that will ensure the engine remains healthy. So that's a preventive maintenance. That could be condition based maintenance. You look at the condition, you do the inspections, and then decide whether this is possible. And one that comes to my mind is the brake shoe of this thing. You look at brake shoe is almost worn off, the condition is not good. Now you're not able to, before it completely gets worn off and you have a brake fail, you try to look at that and then do the maintenance. So that could be something that is. Now what we have now is something that is really taking the bar up. The predictive maintenance and the prescriptive maintenance. Let's look at predictive maintenance. This is what I'm talking about. We're talking about algorithms, which could be could be physics based, or it could be also machine learning algorithm, or and when we are talking about multivariate. So you've got multiple variables that are involved. It's just not just when the temperature is high you do this. It could be temperature, it could be pressure, it could be the differential pressure across a filter, and all these things. So that is where it becomes predictive maintenance. Where you're able to predict as to when this can have a failure, and so once you're able to predict that, and then based on that, what maintenance you do becomes a predictive maintenance. Now, similarly, you have prescriptive, where the assets can be given. See, if you have the knowledge of the process, you can prescribe what should be done, and based on that, the decisions can be carried out. You see. Okay, so these are something that's generally carried out in an industry. Most of the industry today are in this, the preventive and the reactive maintenance. So that is where we are really losing time. We are, because of this. Because in case of reactive, anyway, it's a loss. In case of preventive, you're stopping and then doing. So it may not be necessary at that, especially when the asset value becomes very high. Stopping it every now and then also is going to be expensive affair. If you look at HT motors, you have HT motors and all that. They cannot be started stopped every now and then. There is a particular, because once it starts and once it stops, there is a cooling time and all those things involved. So it becomes very important, that preventive maintenance strategy does not work every time. So that is where this thing comes, and this is what is the today's technology, or where the industry 4.0 is moving, where we talk about predictive and prescriptive maintenance here, and that is what is more important from when we talk about condition based, part of it actually is used for the predictive maintenance. So it's not completely a preventive maintenance kind of thing, but the condition based is something that can be used for predictive analytics. Okay, so far so good.
Great, sir.
Yeah, thanks. So, okay, so now we look at what is condition-based, maintenance. Now, I just put across, some of the curves. You can look at, So now this is the maintenance based on the asset condition. The asset condition is monitored. Now, how do you monitor the asset condition? Asset conditions can be monitored using multiple sensors. Now, you have smart sensors today available. I'm going to talk about some of them. One of a typical use case I will look at, how we do a predictive maintenance for a generator, how it is done, what are the various steps and all that, and that's what you will look at in the subsequent presentation. On so there are these sensors, which tell you a lot about what's happening to the machine and about the condition of the machine, and based on that, with certain logic and model, you are able to tell, yes, this is where. And if you look at the costs initially, if you do a planned maintenance, the costs are very high. Because the costs are high, the repair costs are low. If you look at that, the repair costs are low. The red one, if you see here, are low when you are doing it in a planned way, because the machine is fine. But look at the prevention cost. Look at the prevention cost is very high, because you're taking a downtime of the particular equipment. Your production is stopped here in this case. So if you add the production value, that is where it really, the cost is very high. But as you go towards condition-based maintenance, the price keeps coming down, whereas the repair cost keeps going up, because you are waiting for something to happen. As I said, if you replace the brake shoe irrespective of the failure every 100 kilometers, and you've been riding on a very smooth road without brakes, no traffic, obviously you're spending more, right? But whereas you really look at the condition of this and then repair, which actually we do, so that is where the cost comes down. But again, it could be sometimes higher of the replacing. So that is where it keeps coming. And when you have an unplanned maintenance, everything is very high, right? So this is where this is how we look at, and that is where we have to find the optimal time. This is what condition-based monitoring does. It gives you the optimal cost of maintenance. So that is very important. So this gives us increased availability, because the number of failures are less, reduced cost because the costs are minimum, as I said, and because of this you have an extended life, and then you also carry the less inventory for spare parts, because you don't need to stock it at this point, but you need to bring in sometimes at this place, so that you have a minimum cost of inventory. Okay. Now, when can the failures be detected or predicted? So if you look at the condition of the, here again we are talking about a particular machine, and from the failure you could probably, some of the signs can be as high as 1 year. because you can know that there is certain things that have changed. Obviously, as I said, many of these are rotating machines, and we are able to get a lot of information. Let's say even a small. Let's look at the bearing has gone. What happens when the bearing wears out, or it starts wearing out? It's not completely worn out, but starts wearing out. And your vibration on the axial axis will increase. So you can see a axial vibration coming up because of this. So you will have, and you can detect that. So that could be there, and that's when there is something going to happen. And then as the wear out increases, your vibrations keep increasing, and at some point of time it is going to fail. Now, when is that you should do this kind of maintenance? So this is what you're going to do a prediction of the failure. So based on the models and if instrumentation available, we can create a digital twin, a digital twin of the particular asset to really know the condition, and then really find out when is that I could do, and probably I could do when the cost is less. Maybe this would be the right time to do, or this would be the right time to do. That is what will be determined by the customer, or the production in charge, because he knows, or he or she knows when is the right time, and when is the lean period for the customer to really take a shutdown and do this kind of maintenance. Yeah. So you see, you understand, how condition-based monitoring is helping us, get take advantage of, extending the life cycle of an asset. Yeah. So how does this work actually? Condition monitoring for an electrical equipment. Let's look at an electrical equipment. So there are these things. So a motor will have, as I said, a temperature. It could be a winding temperature. It could be a bearing temperature. It could be a vibration sensor on the near the bearings. Some of these things, and it could be current monitor on the to measure the harmonics and all that. So many, or it could be moisture sensor. That's causing this. Especially moisture can be a big hazard in industry. So if you have moisture sensors, so all these signals are able to tell you. Just a minute. Okay, so these sensors are able to tell you, what is the actual condition of the equipment. Now, then you build monitors. Then you build, kind of a model that is going to, make that's going to realize what is happening to the conditions, which actually estimates the condition, what is happening. What could be there. So that's where in the software, or the system that we're talking about in asset performance management, takes the signals, analyzes, runs a model, and then gives the actual condition. And once the condition is given, it's up to again the operations or the maintenance in charge to really decide as to what would be the right time to do this. So all this data is available at one single place. So getting all this, whether it is temperature, all these sensor data, evaluated into the right conditions, put in a format that the operations or the maintenance person can understand, is able to read this, and then take informed decision as to when should be the time to really take maintenance of the equipment. Yeah. So this is how, and then you have the complete, similarly like this. We have for multiple equipment. So that way you have the complete information about the whole plant, and and many of these equipment are interconnected. So that gives you a picture of what really is happening. Okay, at a plant wide, so a top management, the maintenance head of or the operations head really knows what is happening, because he or she has the complete view of what is really happening to the various equipment in this field. So that is what is the strength of digitalization here. You see, you get, and this is the technology, you use IIoT, what we call industrial Internet of Things, to connect to the systems out here. Then you use the today's advanced diagnostics and analytics tools out here to run powerful algorithms to make the conditions, and then provide an interactive user interface to give all the data in one place, and that enables the decision making by the organization as to what needs to be done. Okay. So yeah. So how is it typically done? I'm just putting a very broad architecture what you can look at here. Yeah. Okay, so today if you look at multiple equipment that are there in the field today, it could be a drive, it could be a motor control, it could be transformers, and all these things, so they are all connected, and all the information is coming to the asset management platform. This is a software platform which uses the technologies like IoT to get data into this, and then each of these is modeled, right? Each equipment that is giving information has a model, which is very similar to a digital twin of what is this, and there you have the inferences from the multiple inputs that you got to decide what's happening to the particular equipment, when does it need maintenance and all that. So that is what could be there. So these are the models that are deployed on this particular platform, which will work and then give you input. Now tomorrow you need, and there is generally all these are stored today. The cloud computing gives a lot of flexibility in terms of the models that could be developed. So there could be a lot of models that are already developed for various equipment, and today you may have only X number of equipment, and tomorrow you add a different Y equipment or a Z equipment into this, and all you need to do is go to the cloud, look at what is the model that is available in the library for the new equipment that is added, just add it to them, and then here you have a platform that is having all the information given to a maintenance manager to take informed decisions on when to really take an equipment for maintenance, what's the condition, what needs to be done, and all that. Yeah, is that clear on any doubts, any thoughts on at this point of time? Hello?
So participants can post their questions in the chat box, or they can unmute themselves and interact with the speaker.
Yeah, I was audible, right, for all this while? No problem in the voice and all
No,
that?
sir, it's fine. You're audible, sir.
Okay, great, thanks. So let's move on to the next part of it. Okay. So now let's look at predictive maintenance. Okay, so mainly it's the what we talk about. When we talk about predictive maintenance, it uses software and hardware tools, and it's just not tools. It's when we talk about it's not just about hardware and software tools that you're going to do. There's also a human element to it, to monitor the equipment, systems, conditions, and all these together. We are able to analyze and then come up with a kind of a predictive definition on how and when can really an equipment fail, and then that is what would be required to prevent such kind of failure. So all this judgment comes. It's just not the software and hardware tool, but it's also in some cases a human intervention also may be required. It may or may not be required, and it could be automated to an extent where it may not be required, but today, with our own gut feeling, with some of the sensors being not available or some of the equipment being so old that we're not in a position to put sensor, there is a human element also possible to add. So all this together actually makes a predictive maintenance model. Okay. So let's what exactly, how does the predictive maintenance work? Predictive maintenance mainly needs data from the equipment point of view, because if I have to write a predictive maintenance module, I need to understand the equipment specification. That means, again, I'm trying to give you examples so that you are able to relate it much better. So let's talk about we're going to do a predictive maintenance for motor. So now, what are the motor characteristics, the motor equipment specifications? The specifications could be the voltage, rating, could be the rating, the voltage, the current, all these things, and the allowable vibrations that are possible, the maximum temperature of bearing or winding that is possible. So all these are actually and what is the load cycle that the motor is designed for. All these things are very important, because I need to read all those things into the system, and then based on those and what is the current conditions, what has happened in past. So all these things are used to come up with what exactly is going to be a model that is going to predict as to what is going to happen to a particular equipment. So that is what is required, and this helps, this data helps us in scheduling the maintenance activity. Got it? So it's very important. And what do you get out of it? So when you have all these available, you talk about increased equipment efficiency, reduced operational losses, minimize the probability of unexpected failure, so you know what's happening, reduce the maintenance cost, and it could also lead to an unexpected failure could also lead to secondary damage. I'm telling you, in case there's a petrochemical complex, and a lot of these the chemicals that are there, they need to be maintained at a particular temperature, and in case of a failure of a heater, a heat exchanger or a heater or any of these things, could lead to solidification of this equipment within the pipes, and then you will have to cut the pipes, flush out, and that's a huge expense that comes out of any of these unplanned downtime of some of the equipment. So these are called the secondary damage. It could, and sometimes it could even go it could be life threatening also, some of these damages. So that makes it very important that we are able to really use the predictive maintenance to a maximum this thing. Yeah, this also improves, because you are maintaining it well ahead of time. It also helps you extend the life of the assets, and because you are able to run it a much better way, you are also improving the overall product quality of. So these are some of the advantages that come out of going for a predictive maintenance. Yeah. Okay, so let's look at some of a typical example of how predictive maintenance kind of helps us reduce a significant loss that could have happened. You see, here we are talking about a cone crusher. A cone crusher is something that is used in a mining operations, and it will typically have a hydraulic system that is going to be used, and hydraulic system, then there is a cooling system and all that. So then you find there is a air filter. The air filter that was used for this particular has got a blockage. So generally we are measuring the pressure across the air filter to see that the filter is working properly. Whenever the pressure increases, that means there is a block in the air filter. That means air filter is not working efficiently. The air filter does not work efficiently means it will lead to contamination of the hydraulic unit. Contamination of hydraulic unit will lead to again the oil filter getting clogged, and when the oil filter gets clogged, oil temperature increases, and the temperature increases, and then you have the bypass valve open, because it has to be vented out. The heat has to be vented out. So this leads to overall, complete down the whole cone system not being working. Now, if you look at the alarm, if this was the alarm that was detected much earlier, before any of these things happened, so and then you, with this air pressure drop, you find that there has to be a air filter and the oil filter that needs to be cleaned at this particular time. Otherwise, over a period of time, this will fail. Is when you could relate and then come up. So this is typically a rule-based algorithm. As I said, there is a rule that if there is a clog, differential pressure across the air filter increases, means there is a clog in that, so that needs to be removed, and that would lead to subsequent things. So these are just the rules that have been written. And here, if you look at if and we are talking about 4,000 tons per hour equipment, and each they have a margin of $15, would also lead to significant even if it is down for an hour, we are talking about a 600,000 loss. Is $500,000, more than $500,000 lost in just a matter of 8 hours. See, so that is where these kind of algorithms help. And today, the equipment, as I said, are becoming more and more powerful. Information is available, so all this is possible, and hence, this could be, done. Okay. Similarly, now we look at, where standard rule-based things don't work. So we have, a pretty complex, gas turbine compressor. This is not something where you have failures that could just be, just be identified, and like a rule we do that. Here we need to have the subject matter expert of the gas turbine will define an asset model as to what are the inputs, what are the possible failure modes that could happen. All those things will be defined, and those then again using the standard the today's artificial AI or ML models and all that, you could model these things exactly, and then derive a particular what is the action to be taken and all that. So that all can be kind of coming out of this. And you see here again, the cost of this thing is very high. Again, gas turbine goes down. One is, these are all very rare occurrence, but if that goes down, it's a huge amount of revenue loss for the company in terms of these things. So this is where we will have the modeling coming into the picture, where the standard rule-based things don't work. In many of the cases, the standard rule-based or physics-based models don't work. So then you'll have to come up with your own experience, as well as multiple dimensions coming into it, a multivariate model you could make, and then based on that, inferences could be arrived, and that could help in predictive maintenance. Okay. Now you see, today, how are we deploying today asset performance management, system? There are many ways, it could today with, the reason is, as I said, these are pretty complex, algorithms that need to run, and to need a very high computing power. And today, with cloud computing being really something that has come up, and where we have a very powerful way of computing all those things, and doing that, cloud-based models are quite common. So today, from we can offer, wherein if you look at these are some of the connected devices that are there. Then there are OT systems. OT is operations technology. IT is information technology. ET is engineering technology. Now, what are OT systems? OT systems are that give you that are control systems. That could be control systems, and from where you are able to control the whole process. You're able to get the process related data. That's why we call OT systems. Then there are IT systems, which are something like ERP or maintenance management systems and that kind of stuff. And then you have ET systems, the engineering systems, where you're designing, where you're keeping all your design documents and such kind of stuff. So we need information from all these equipment, and that is taken via edge device into a cloud. And here we are able to model a particular equipment and then draw the inferences. So and you could then be connected to this cloud anywhere, and then you are able to see what is happening to the plant, what needs to be done. So it could be the maintenance manager is away, not in factory, but is connected. So he or she connects to the cloud, looks at what's happening, and then gives instruction to the maintenance team that needs to be what needs to be done. So, or an expert could be looking at into a particular scenario and then giving guidelines of how remotely all these things could be managed. So that is what is the power of cloud today. And again, it could be I am just giving an example. As an ABB, we offer this. What we call today, you would have heard software as a service. That means all customer has got this, and we say, okay, we will ensure, we will give you an uptime of this particular equipment in France. All you need to do is per equipment per year, you pay me this, and I'm giving you all the inferences available and running all these things on my cloud. So that is something called as software as a service for this. So we can do for multiple customers in the cloud and then manage and then do that. So that's one way of doing it. But many of the customers today are hesitant about giving the data into a cloud like ours. So they don't want to share their proprietary data into the cloud. So they could have their own cloud. The cloud that they have got control. Again, it could be a public cloud, but then managed by them completely. So we can run it there also, and then do the same thing. Or it could be an on-premise setup. So all customer needs to then invest on huge amount of servers and all those softwares and all that. So then we run these models and the complete APM software here, and then we are able to give inference based on this to the people, the maintenance and the operations people. And however, it could be also on a customer private cloud. It does not want on-premise, but they have their own data center where they have all those things. That's also possible. So these are multiple things as to how typically an APM project would get executed, and we are working in all the configurations. So one of the project that I'm currently working on is where a customer has a Microsoft Azure cloud. He is kind of rented it for himself, and then we are deploying our solution on that particular instance of Microsoft Azure, and then customer is able to look at the data from their cloud directly. We have also cases where we are doing it on our cloud, and then we are giving them, in fact, services as to how and when they should maintain, expert advice, and all those things. So all these are possible with this. We are working with projects where customer does not want to send data to cloud. They're very apprehensive about data going to cloud and all that. So this is also there. Yeah. Okay. So now, how is this? If and we, as I said, we are doing this for multiple customers. How it is impacting them. So we've done the project for an oil and gas major where the real-time data is available on ABB Cloud. This is what I was talking, and then we are giving them inferences on their platform as to what is happening, what they need to do, and all that, which is helping them extend their asset lifetime and also increasing their operational capacity. Similarly, we are doing it for another energy major and we are giving them data, data that is enabling them to take operational decisions to do this. We're doing it for a gas distribution agency on how the data is moving. We're doing it for a water distribution company on again data that is coming onto the their cloud or our cloud, and then we're able to tell where are the leakages, what they need to do, and how overall their energy efficiency can be increased, and so on and so forth. So these are okay. Now, as I said, we will just briefly look at how typically we are carrying out a predictive maintenance of a generator. From this is an ABB example that they're given with some of the ABB products and solutions. I have not named any of them explicitly, but this could vary a little bit from company to company. So what I have done is what I have seen, and so please be aware of that. And in case you find a little bit different, this again could be architectural difference or the philosophy difference between the various companies, because there are similar companies like ABB who do this and offer different solutions. But I have tried to make it very general. But please forgive me in case you find it very specific and you heard that it is not exactly like this. That could be a difference in the architecture. And okay, so let's look at a particular generator, and so why do we need an optimized maintenance plan? As I said, the optimized, you need an optimized because one is to really take the maintenance when it is really required. And how can you give an optimized maintenance plan? Is by it could be by physical inspection, which is there is an air gap inspection. So the air gap between the stator and the rotor, that could be looked at. MaxSense is a smart sensor by ABB, and it can sense a lot of it can give a lot of information about the motor and the condition of the motor. We will see that in the subsequent slides. Then we can do a life expectancy analysis of the particular motor as to how long it can run, what is the condition and all that, and do actual survey of the site, and then discuss with the customer on the maintenance schedule and how it is going to be working and all that. All these put together, we can really come up with a maintenance plan wherein the customer can really extend the life of or can extend the maintenance period, delay the maintenance rather, I would say, is to get the maximum out of the machine and have the minimum cost of maintenance. Yeah. So we use the condition-based approach, and we use both non-invasive monitoring process. That means we really don't need to take out anything and do, but at some point of time, for some of these things, we could also need some invasive method. But again, these are all minimal invasive methods, so you really don't need to take out the whole motor and then do the inspection, but it could be something that needs to be done. Okay. So again, finally, the idea is to increase the availability, bring down the risks of any unplanned shutdowns and unexpected failures and all that, and maximum the uptime with ensuring that the maintenance planning is done properly, and it also. See, one is, we could, delay, but then if that leads to unreliable operation, that is also not something. So it has to be reliable, and it has to be also prolonged. So that is where, we are, kind of working on for an optimized maintenance plan. So what actually, if you look at a synchronous machine, what are the things that generally fail, We have, if you look at the statistics, it is the stator winding that has failed maximum. These are again data that are coming from multiple failures that insurance company has gathered, and so it is. Look at that. It's Alliance statistic that has come. That 60% of the failures are from the stator winding, and the rest are the bearing and other failures, more or less in a very similar proportion. Okay, now what are the root causes for the generator stator failure? Again, the biggest root cause is where the electrical insulation actually fails. And you have sometimes a mechanical failure, sometimes it could be thermal, and sometimes it could be bearing failure. But majoritarily, again, it is the electrical insulation. Now, why does the electrical insulation fail? Again, if you look at that, it's the aging. One is it has aged. It has gone through multiple cycles of heating, cooling, and all that, and it's been used for quite some time. That could be one reason, or it could be contamination or internal partial discharges or loosening, thermal cycling or overloading, or defective corona protecting, or it could be also overloading. So these are some of the major cause for the insulation failure in a particular machine. So this is how we arrive at how and what is really happening, and then we work on that, and then we do a life expectancy analysis. Why is the most critical failure, and what is the condition assessment, what is the expected lifetime, what are the recommendations for maintenance action. So all these are presented to the customer, and how the overall time can be reduced. And yeah. So and then, as I said, using the smart sensors, we are able to get a lot of things. One is the load, torque, temperature, FEM model for faulty this thing, flux force, all these things, speed, torque, all these are captured by the smart sensor, and it's available we have our own dedicated software where it is available, and these are available for everyone. So today's world, almost all vendors have got this kind of thing that are used for defect detection, and are able to give what's happening. So whether it's an interturn defect on this, or rectifier defect in case of rotors, or sleeve bearings if there is excessive or unequal clearing. Similarly, in case of stator, is it the core looseness, or the supply quality? We also check the supply quality in terms of harmonic distortion, or supply unbalance, or over voltage, under voltage, or frequency changes, and all those things. So the smart sensor is able to give lot of this information about this thing. Then yeah. So there are so there are some things that you can do when the generator is running, and there are something for which the generator needs to be stopped. And once we do this, then we are able to come up with an optimized plan. So what the smart sensor is able to get the data while the generator is operating. We could do operating data analysis in terms of the current, torque, and all those things, whatever, how the motor is or a generator is working. Then what has been the operations and maintenance history, and what could be the down impact of on the business. So all these can be done when the generator is operating. But some of those things, when to look at the rotor, to do the life expectancy analysis, mechanical checks, and so these are something that's where we would need a generator to be stopped. And then based on this, once we have this, we could have the stocks ready, and once we have this these two steps done, we can come up with an optimized plan of how a maintenance of a particular machine, predictive maintenance, could be carried out, and when and what is required. So when should the rotor removal is required, or when is that really can be done. Okay, so these are some things that come out of it in terms of the operating data, the bearing condition analysis, or the electromagnetic defect analysis, or the power. So all these reports come out of based on the smart sensors. Um, the inputs that are there. So the ABB's a typical motor analysis. So I should not say ABB. It's typically a motor analysis software with the smart sensor is able to give you all these kind of inputs, which help in taking. Similarly, when generator is stopped, you could look at the contamination, slot discharges, surface discharges. Some of these things you could look at, and then based on these two inputs, then come up with so again, these are all physical inspection that can be carried out, and then we could come up with a plan. So see, and yeah, once we have these done, we determine a severity factor as to what could be the severity of the failure, and similarly what could be the serviceability. I mean, how it is, how much time, and what would be required. The MTTR, the mean time to repair, how much time it is required. So once we have both these things, we really know what is the impact factor, which is the severity versus the serviceability, and that is what determines when should actually a machine be taken for a maintenance. Yeah. So based on these things, we could then come up with what can be done, what needs to be done immediately. Which are this is read in the thing. This has to be attended to immediately, and something that could be done during the next 1 to 2 years. What could be done in next 2 to 3, and all these things. So this is what is actually typically how a condition-based monitor, predictive maintenance. Using the condition-based and the analytics, we are able to do a predictive maintenance of, give a predictive maintenance schedule for a particular machine, and this becomes very important for the end user to make sure the assets are used and right. And this is an example I've shown, and the same principles can be followed for any equipment that you can think of. So that's the same philosophy. You will have a physical inspection, you will have a sensor-based inspection, and all that, and then come up with what can be done, what needs to be done, and what can be done. Yeah. Okay. So, and then we will come up with the indices of what is. Of course, these are very small, but when I give you, probably you can have a look at this thing. There is a impact, and then there is a condition factor, and the highest one is something that needs an immediate attention, like stator end winding. There is a erosion on that. Similarly, rotor winding. There is something that needs to be done. So this is something that has to be handled, and yeah. So based on that, there is a maintenance schedule that could be drawn. What needs to be done, when we need to run the max sense, and when we really need to carry out the maintenance activity for a particular generator. So this, yeah. So yeah, I mean, so this was what was all about. I talked about how what are assets, and what is an asset management, and what's a condition-based monitoring, what's a predictive maintenance, how do we do a predictive maintenance for a particular equipment, just to give you an idea on what it is done. Yeah. So all good as of now.
Yes, sir.
Okay, good. Yeah, we are almost okay. So now I will just talk about what we did in some of the some of the customer place. As you see here, it's a sugar plant here, and and there was and this needs to run continuously, and it has to run without failures and all that. So and in this case, it's mainly the availability of electrical system that we were talking about, not the mechanical part of it. So we were collecting data from the relays, transformers, voltage to predict the failure. And with this, with the online condition monitoring for the breakers and switch gears for maintenance planning, and converting data into online, so you could have dashboards created like this, which is showing what is critical, what isn't critical. So an operations man is able to that way able to take informed decision on it. And what resulted by doing this was at least 2 4-hour electrical failures which were happening prior to all these were avoided, which resulted in $250,000 of savings. I mean, which Indian rupees comes to about 6 crores of, because that's a huge money, right? So 5 to 6 crores of rupees were saved. Maintenance costs of about what it's about 35 lakhs or something like that saved, and then overall 15% additional saving because replacing the equipment at the right time, not investing. So that's how overall it resulted into saving. So that is what, and these are the real life examples of how condition monitoring for electrical equipment have been applied. Okay, now we look at look at a particular it's a mining customer. It's a big mining is a big business actually, and here you can see the losses can go into multiples of multi-million dollars, unlike a sugar plant. Sugar plant is a small plant. It's not that critical, but mining because they produce almost 6,000 tons of iron ore every year using about 6,000 assets, and so we were monitoring all these assets and giving the asset health status as to which equipment has got what is the status, whether it's red, green, yellow. So where the maintenance needs to be carried out, where they really need to focus on, and all that, and all this really helped with early warnings, and 88 maintenance work orders to relieve for these 6,000, resulting in savings of $5 million in terms of spare parts and material costs and man hours. And then also if there was a production loss, it could have caused the 4.6 million tons of iron ore production loss, which would result in a These are again notional, right? I mean, this has not happened, but had any of these things happened, this is what would have been lost to the company. So this is another example of asset management in iron ore. And now we look at hydro. This is a large large hydropower company in Europe. Can't name it. Even if it is named by mistake, please ignore it. I'm not sure. I tried to remove all the names. But yeah, so again, these are early warnings and overall performance improvement, and the maintenance cost coming down by 2%. Overall, 10% increase in performance, and early notifications for more than 6,000 assets. So this is what we are able to do. This particular hydro company is tied up with us, and we are looking for a very big opportunity in the coming days with them to make sure all the assets are covered by them. So what I want to say here is, this is what customers have started realizing. There is a lot of investment going on to this. And this is really a very interesting field for the young engineers to be in. Similarly, we had a cement customer where we could reduce their overall operating cost by about 3 to 5%. Here we have not only with the maintenance data coming in, but we also have a lot of group-wise integration of data, including data coming from their laboratory systems, the ERP systems, and all that to help really operate the plant to the optimal level. Aided with that was the predictive maintenance stuff. So overall, increasing a very big, savings for them. And if you look at here, we are talking about a payback of less than a year for the kind of investment they are making. That's something great, right? I mean, you borrow money, put up a facility, and then you're back, and that year you recovered back whatever you invested, and next year is all like additional profits. So this is something that is interesting, yeah. Similarly, again, cold rolling mill. For those who are not aware of what the cold rolling mill is, a cold rolling mill is a steel plant where the sheets, sheets are rolled from a higher thickness to a lower thickness, and generally all these the output of these mills are used for cars, refrigerators, the sheet steel used for cars, refrigerators, and that kind of stuff, or daily use sheets that we use. Here again, using our overall data that is coming from multiple of these, using data coming from all the equipment, we were able to improve the overall equipment utilization from 36 to 43%. So overall, a huge 6% increase in the a 7% increase in the, which resulted in a 32 ton throughput increase, and then a 5% decrease in the maintenance cost. So that's also €500,000. So that's big. I mean, again, talking about 4-5 crores of rupees. So this is what is making people go for all these things. All these. Similarly, we had a customer who had a very old chemical plant, and they wanted to extend the life of the operations, and some of these equipment where we could do an analysis and all that, looking at the what we do, asset life assessment. What is the next remaining useful life of the equipment. So we were able to work with them, and then identified that some of this could be used, repurposed, and used for another next 20-30 years. So all this, again, a payback of less than a year here in this case by doing all these things. Yeah. Okay. So just looking at some of the cost savings that these kind of projects have done, a $12 million improvement for a large chemical company, or a 10% increase in the generation, or for oil and gas, the turnaround intervals increasing, or a 90% reduction in the offshore work. So all this is how APM has actually kind of impacted. Yeah, I think I have spoken a lot right now. So we got another 15-20 minutes. If you have any questions on this, or please feel free to ask. I would be happy to talk about this, or I can also have I have other collaterals also. If there is something that is required, maybe I could speak about that.
Thank you,
Do we
sir.
have any questions on the? Sorry, I have not seen the chat window because I was in the presentation mode.
I request all the participants to post their questions in the chat box or live YouTube channel comment section, or also they can unmute themselves and interact with the speaker.
See something? Okay.
No, sir. Right now there are no questions.
Right now, no questions. Okay. Um, So, I mean, any thoughts on this? Even you could speak. I mean, if you found this was completely irrelevant for you, or was something that that you find it is interesting, or yeah, or it was something that probably need some more. I can speak in that. Okay, stop presenting now.
Sir, I have a question, sir.
Yes, please.
Sir, regarding the cloud feature, what you explained,
Mhm.
if the customer has to use the cloud which is provided by ABB, so
Yeah.
like it will be charged, or how, what is the strategy you all have, sir?
Yeah, exactly. As I said, today, see, the whole thing is the what cloud-based, kind of solution gives you an advantage is, the customer need not invest on the hardware. You see, if I have to do, run all these algorithms and all that, I would need a very, good amount of computing power at the customer place, which would involve mainly, setting up of a small data lake, and have all these components. I mean, just giving you, there is a data lake, there is an application layer, there is a visualization layer, and and there is a layer where all these models are run and all that. So this would need a huge amount of computing power. Now, one is
Correct.
customer has to invest on the on these kind of servers, and the high-end servers and the softwares and all that, and then have people to maintain them, and have people to maintain this. The other way is, okay, I don't need, I just give a PC, an edge device, and it gets connected to the cloud, ABB's cloud, and ABB does all these computation and gives back the inference. So all you just need your laptops, and and the mobiles, just to connect to the cloud and get all the inferences. They don't, customer need not invest on the software. On the software, customer need not invest on. All they have to do is play annual. Like what is there, right? In Office 365, you can pay annually, and you have the Word and all the Office applications available to you. You have to only pay annual subscription charge. That's how Microsoft has come, and that's all. Or it's like Netflix. You pay every month, you get, the day you stop, you don't need, you will not get. And all this is the device library. Everything is available in the Netflix server. So you have the choice to take and then see what you want. And same thing happens with the cloud-based application also, where you look at the application and then do it. So you don't need to invest on any of these things. That's the trend, actually. Software as a service, what people call it.
SaaS it's called, right,
Yes,
sir?
double AS, yes, SaaS offering.
Okay.
Yes, double
Okay.
AS.
Okay, sir.
That's the trend now, because of a lot of these data centers. Again, this has, as I said, downside of sending the data over internet to a public cloud. Again, there could be potential theft of data and all that. So, but while we as ABB are taking care of all these things in terms of
The data security has to be ensured,
yeah,
right,
yeah,
sir?
we are ensuring that. So we are completely cybersecurity compliant. All our products are compliant. We use products that are cyber secure, safe, and we also provide the cybersecurity services to ensure that these things don't happen. So, so that way, every company is today is able to do that, and that way it can still be protected, because still a good amount of data is residing on public clouds like Azure, or Google, or AWS, and all these yeah, cloud service
So
providers.
almost all the industries are having their own private
Yeah,
cloud.
many of the industries, especially, you see, again, it's all data privacy issue. A bigger industry, like if you look at, enterprise like Tata, or IOCL, or ONGC, they have their own, cloud and their own data center, and they do all these things there. But the smaller enterprises, which could not be there, and why should they really invest on, on the hardware, on the people to maintain this hardware and all that? And they would go for And the deployment is pretty fast. It can happen within months, and you have a solution up and running.
Right, sir. Thank you, sir. Thank you.
Any other questions can be asked? Thank you, sir, for addressing the question. All the participants are requested to fill the feedback form provided in the chat box. Filling feedback form marks the attendance for today's session.
It gives me an immense pleasure to deliver a vote of thanks for the
Just a minute.
Yes, ma'am.
Varsha, see, there is a hand raised. Miss Sugandha has raised her hand. Please see if she has a query.
Yes, Ms. Sugandha, have you any doubts regarding the session or any questions? You can unmute yourself or you can post the question in the chat box.
Miss Sugandha, are you there? Sugandha?
Muted actually. So.
Okay. I'll get back to her later. You can continue, Varsha.
Okay, ma'am. It gives me an immense pleasure to deliver a vote of thanks for the event to all the dignitaries. On behalf of IEEE, KLSGIT, and all the audience, I extend a really hearty vote of thanks to our speaker, Mr. Suhas Kulkarni, who spared time from his busiest schedule to grace the occasion. Today, we had an opportunity to hear your thoughts and ideas, and this will surely encourage us in our future endeavor. We thank all our professors for your constant support by organizing such significant events which boost our zeal to learn.
Lastly, we would like to thank all the audience for being a part of this session and also turning up in the large numbers in this session. Thank you, one and all.
Thank you.
Suhas, sir, if you could just share your communication.
I have done that.
Yes. Got it, sir. Got it.
Yeah. So any questions, anybody can always, please feel free. We can also connect over phone if anything is required. I'm more than happy to help the young engineers, aspiring engineers in any of their this thing. Yeah. Thank you so much. It was my pleasure to be talking to my friends in GIT and our esteemed professors. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you. Bye.
Uh, Dr. N.R. Srinath, no, there is no other form for attendance. You can go for the link only.
Just feedback is enough.
Sorry.
Just feedback is enough. There is no separate attendance for that.
No, sir, it will be
No, sir.
considered as attendance.
Oh yes, thank you.
Thank you, sir.
Thank you, sir.